You know that feeling, right? You try to copy some text from a PDF, and what you get is just a complete mess? Yeah, we've all been there. Well, today we're diving headfirst into that chaotic world of digital documents to look at a brand new AI model that's trying to clean it all up. It's called Dots.ocr, and it's a pretty small model that's making some seriously big waves. So, let's dig in.
Here's what we've got on tap. First, we're going to tackle what I'm calling the document dilemma. Then, we'll check out the unified solution that Dots.ocr offers. After that, we'll see how it was put to the test against the big guys, understand why it's so small but mighty, and finally, we'll look ahead and ask, what's next for documents?
All right, let's start with a problem we all know way too well: the document dilemma. Why is it so incredibly hard to get clean, structured information out of a digital file? It feels like it should be easy.
So let's just put the question right out there. Why are these files, which look totally normal and organized to us, such a massive headache for computers to understand? Well, the answer is all about the huge gap between how we see a page and how a machine reads it.
See, a document isn't just one big chunk of text. It's this complicated mix of paragraphs, columns, tables, crazy math formulas, images, you name it. Our brains instantly get it. You read the left column, then the right one. But for a machine, that logic just isn't there. It just sees a bunch of separate pieces, not a cohesive story. So that brings us to our next part. If the problem is all this chaos, then the goal has to be finding a simpler, smarter way to deal with it. And this is where the story gets really, really interesting.
You see, the old way of solving this was, well, it was kind of a Frankenstein's monster situation. You'd have one AI model that was good at spotting text, another one just for finding tables, and then another one to figure out the page layout. You had to bolt all of these things together in this clunky, super complicated process.
But what if you could just throw that entire messy toolbox away? What if you could do all of those different jobs, reading the text, understanding the tables, figuring out the layout, with just one single unified model?
And this is it. Meet Dots.ocr. It's what's known as a vision language model, or vLLM, and it does exactly that. It doesn't need a bunch of different tools because it was built from the ground up to see a document the way we do, holistically, understanding the layout and the words all at the same time. This slide really says it all, doesn't it? On the left, you've got the old way. Complex, heavy, with a different tool for every job. And on the right, you've got Dots.ocr. Simple, a single model, and totally unified. It's less like a messy toolbox and more like a Swiss Army knife for documents.
Of course, a new idea sounds great, but talk is cheap, right? The real question is, how does this little model actually perform when it goes head-to-head with the Goliaths of the AI world? Let's look at the numbers. To find out, its creators put it through the ringer on something called OmniDocBench. This is a really tough standardized test for document AI. And who was the competition? Oh, just some of the biggest names out there, like GPT-4o and Gemini 2.5 Pro. No big deal. And wow, the results are pretty wild. The number to watch here is edit distance. Just think of it as an error score. The lower the number, the better. And you can see in the overall column, Dots.ocr actually beats both Gemini and GPT-4o. But check out the read order column. This is the one that shows how well the model understands the flow of the page. With a score of just 0.040, it is best in class. It's not just reading words, it's getting the story right. Okay, so being a champion in English is huge. But the world's documents come in all sorts of languages. So what happens when you throw some of those low-resource languages at it, the ones that usually get left behind? And this is where Dots.ocr really pulls away from the pack. On a special multilingual test, it established what the researchers called a decisive advantage. I mean, look at that overall edit distance again. Its score of 0.177 just blows Gemini's 0.251 out of the water. This isn't just a tiny win. It's proof that this thing is seriously capable across a ton of different languages. So the big question is, how? How is this smaller model getting these incredible state-of-the-art results? Let's break down the secret sauce here. First, and you might want to sit down for this, is its size. Get this. Dots.ocr has just 1.7 billion parameters. To put that in perspective, some of the giant models it's competing against have over 70 billion parameters. It is incredibly compact. And that small size is its superpower. It's what lets it deliver that powerful performance we just saw. It's why it has such great multilingual support. It's all because of that simple, unified architecture. And best of all, Being small means it's efficient and fast, which makes this kind of powerful AI way more accessible to everyone.
Now, this is all incredibly promising, but it's not the end of the story. So for our last section, let's take a peek at what the road ahead looks like for document intelligence.
But look, no new tech is perfect right out of the gate. To get the full picture, we've got to be real about the current limitations and see where a model like this still has some room to grow. The source material is pretty clear on this. There are 3 main areas for improvement. First, super complex tables and formulas can still trip it up. Second, right now, it sees that a picture is on the page, but it doesn't actually understand what's in the picture. And finally, it's not yet built for processing millions of documents at lightning speed. But here's the thing. These aren't dead ends. Not at all. The team has a super clear and ambitious vision for where this is all going, and it tackles these challenges head-on. On their roadmap, getting even better at those tricky tables and formulas. And yeah, you guessed it, actually parsing the content of images inside documents. But the ultimate goal is even bigger. They want to create a general-purpose perception model that can handle all kinds of visual understanding in one shot. And that leaves us with a final, really provocative thought. We started this whole journey with that simple frustration of a bad copy-paste from a PDF. But what we're looking at now points to a future where a single AI might not just read the text, but understand the chart, interpret the photo, and grasp the entire meaning of a page, just like we can. The quest for truly intelligent documents, it's really just getting started.